Well, we're going to talk about really executable specification here. This is something that I'm super excited about and doesn't have a darn thing in the world to do with .NET. I just happen to live in the platforms for the most part, and so the code that we'll look at will be in .NET. But I know for a super duper fact that everything we're going to talk about is fundamentally applicable in almost any programming language you can imagine. Certainly Java, Ruby, those sorts of things. Hi, I'm Dave, and there's me. If you'd like to send me mail or talk on Twitter about any of this stuff, this executable spec thing is a total passion of mine. I eat it up, and I would love to have as many conversations about it as you'd like. Okay. This is how we did software for a long, long time, right? Anybody still doing software development like this? Really? Nobody's willing to admit this. Okay. Just a couple. Only when you're forced. Okay, so we did that for a while. Then we learned that this was better, right? Now I'll tell you that, I don't know if you happen to notice my title, but I work at scrum.org. That means that one of my bosses is Ken Schwaber. And one of the things that I had to admit to him is that when I learned how to use Scrum back in 2002, 3 time-ish, I actually was running a department of about 50, 60 software engineers, testers, all those folks, and we did it just like this because my QA manager walked up to me and he said, you know, we're about halfway through the first sprint that we were trying after our 2-day certified Scrum Master class. Everything's going to be great, right? So we're about halfway through the first sprint, and the QA manager comes up to me and he says, this is not working. Well, why not? Well, it's not working because we don't have anything to test yet. And the tester's just sitting around doing nothing. And I said, well, geez, I thought we covered in class that you were going to basically work through building up acceptance tests and build the test cases during the time that the system is being developed, and then you know the story. And they said, yeah, that doesn't work. Okay, what do you propose? This is what they proposed. Give us our own sprint. And not knowing any better, again, 10 years ago, I said, okay, let's go ahead and do that. So if a bug is developed here and it's found here, when's the first time it can be shipped? Turns out there. So you've just built a 3-sprint lag into delivery of any working software if you find a defect in it. So that didn't work well either. So we learned to do this, and that didn't go so well. So then we started doing this, and this happens to be what most teams are doing. Those of us at scrum.org refer to this as Scrummerfall. This is what we find in most organizations, and in fact, if you read some of the articles about Agile adoption through things like InfoQ, they'll say that this is far and away the most common form of iterative incremental development, is to do everything we did in Waterfall. Remember that very first picture where you had a long development cycle and then you test it right at the end, and the testers are saying, but we don't have enough time, and developers say, doesn't matter, I'm in charge and the sprint review is on Friday, so take it. And that's what goes on out there. Anybody living that life? One? Come on, really? I don't believe you guys. There's some more of you. All right, this happens to be living the dream for most people. Now, if you actually talk to some of these big old $5 consultants who go around telling you they'll solve all your problems by giving you Scrum or Agile or whatever, they'll tell you to do this. Right? It happens all at the same time. You write some code, you write some tests, it all happens at the same time, man. Who believes that? Me either, because I actually write software for a living. So it turns out that this is a great platitude. This is a great model to talk about. It's very interesting to say that these two asynchronous activities can coexist and go at the same time, but it turns out that that doesn't work in practice. What many teams are starting to have a little success with is a model like this. We do some tests up front. We've changed the way we think about what testing is, though. And then we do some development, and then we do some validation testing. Now, before we got to this place, we thought about validation testing as being the way that software is tested. So validation testing means we make the software, or maybe we make a spec, right? We write something in Word, we write something in Excel, and then we write some software, and then we write some tests, and we take those tests and we validate that the software works the way it was specified in the text. The problem is that we can't compile Word documents or Excel documents. So instead, what we've started doing, and what this test piece means up here, is we write some tests at the beginning, say of a sprint. Let's just say, because I am a Scrum guy and we're talking about iterations here. So we'll write some tests, and those tests at the beginning of a sprint define the scope of the sprint itself. Becomes very simple to be a software developer in this world. Make those tests pass. Well, simple doesn't mean easy, but that becomes the job, and then you do some development. Now, at the beginning, when those tests are being written, that's what testers are doing. They are actually building those initial tests, and it turns out they're very good at this. This is a blurring of the role of business analysts and QA people. I am in a lot of companies and talking with companies about Scrum, and particularly the number one thing is, what do I do with my test and QA folks? It turns out that those people are exceptionally good at writing specification in the first place. They're probably better at it than the people that you have doing it, because those people just want some software. They don't actually understand how it works. Testers do. So they turn out to be really good at writing this initial set of tests. Now, about halfway through the sprint, we've written all those tests. We know that the developers have to make those things pass, and so now we testers can start looking at other sorts of testing that has to go on. We're not going to talk about those things today, but things like performance testing, things like the ILITI type testing that we might do, security threat analysis, whatever. And yes, even in verification of functionality, but very little, because we know that in order to scale to a continuous delivery model, which is what we're all talking about these days, you must be able to automate these things. Anybody in here doing continuous delivery? Really? Let me show you something. Pull up a Windows 8, not used to it yet. Who's seen this? Can you guys read that? Flickr was last deployed 43 minutes ago, including 2 changes by 1 person. In the last week, there were 85 deployments of 364 changes by 16 people. That's continuous deployment. If you're not doing this, you will be. This is what it's like to do business on the cloud. And if you're not able to deliver like this, your competition will be able to pretty soon. Now, the way these teams do that is they automate the heck out of things, including functional regression. All these shops that I walk into and try to say, yeah, we're doing this Agile stuff, everything's great, but we still have this big deficit of automated regression. They'll admit that. It is a problem. So we're gonna get our way out of that. And the way we do that is with this simple little technique here. So what we do is we create a requirement. Initially, I have to see it, unfortunately. We create a requirement, and this, in the context of Scrum, I'm going to use Scrum as a sort of sandbox within which to play because most people know it. Okay, so we go to sprint planning. We sit down at sprint planning, we say, here's the requirement we're going to work on. And then developers, they're really, really good at asking questions that start with yeah, but, right? So the product owner says, we want a set of admin tools into this new app. And the developer says, that's cool, yeah, but what about this? What happens when? What do we do if? What happens when this event occurs in the system, etc.? Now, every time a question like that is asked by a developer, we can answer it, and we can answer it and write down the answer as something we call an acceptance scenario. So you might, for example, say something like, well, given that you have not entered any text into the search box, when you click the search button, then the page does not refresh or nothing happens, right? That's an edge case. Or you might say, given that we've put a search term into the text box, when we click go, then search results are returned. Both of those are acceptance criteria like we're talking about. So we list those, and those are the answers to the questions when the developers ask, yeah, but. Once we have those, for each one of them, the work becomes to express that thing as a test and then make it pass. So at first, the acceptance test fails. So we take that given when then statement. That's just one grammar, by the way. There are lots of grammars out there. This one, given when then, is a very popular one. So we create a failing test with that. Now this fundamentally changes things because all of a sudden the specification is the test and the test is the spec and which one is which, and they're both the same. And that's a fundamental difference. That's almost like you can compile Word. That's almost like I can compile a Word document into a program that's going to run and check my program. And that's exactly what we're after in terms of executable specs. So we automate these acceptance criteria as a failing test, and then, I want to be clear, we're not talking about the typical TDD cycle here. Let's be real clear. That usually happens at a much lower and modular level, and so the way to implement this thing is probably going to use, if you're a good developer and good development teams, they're going to go use test-driven development as a technique, but it stands apart and separate over there to build out the underlying pieces of functionality that are going to be required to make this regression test pass. And then we do that again and again. And that is what the workflow looks like for executable spec. So I like to use the word desirements to talk about some of these things because desirement, I think, is a much better term for something that doesn't compile. If something compiles, I'm willing to call it a requirement. But at any case, here's an expression for desirements, and I'm sure this is old hat for most of you. I'm not going to belabor it. But what we forget about the user story structure often is this. This is that given when then structure that I was talking about. It's a way to express those scenarios. And when we do this, we're able to write out our English or any other languages, it turns out, into something that's compilable. And so now these aren't desirements anymore. They turn into actual requirements. Here is kind of some ground that we've already covered. When this works, we're expressing those requirements in a way that everybody involved in the work can read. Now, I know that this happens because I built some software for a lady named Michelle. And Michelle had no idea how software works, nor should she. That's not her job, that's my job. She understood veterinary supplies. And so she told me how she wanted her website to behave, and after a few days of me saying the following to her, she picked it up. She would say, "Man, I want a screen that does this." And I would say something like, "So Michelle, what I hear you saying is that when there's an item in the cart and we had another item of the same, or when the, blah, 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 given there's an item in the cart, when I add the same item again, then the total count should be 2, something like that." And so I would start talking with her in that way, just over the phone, over Skype, the way we were communicating, and eventually she got used to expressing herself to me in that structure, and it worked just fine. So this is sort of what that scenario looks like. Now, I'll admit that this is an MS test, unit test, so don't hate it for that reason. But do you recognize this as a simple unit test? It turns out that when we test software, in pretty much every case, we do the same 3 actions over and over and over and over. And it doesn't matter what grammar you use. And this is true even in manual testing, by the way. What we do is we set up a system into some initial state, and then we poke at it, right? We invoke some operation, we make some state change on the system, and then we look at the resulting context. We look at the result of that. Maybe it's a return value, maybe it's a new shape to my object graph, whatever, but I'm looking for what happened when I poked at it, And it turns out that this overlays perfectly like this. And this is how many of us wrote unit tests for many years. Anybody doing this now? Cool. So I took that a while back and I thought, you know, I bet you there's a fun, cool way to do that with a little more structure. So let's digest this base class just for a second. I like, as a developer, I like to think in terms of arrange, act, assert. It's just the way I think. So I'm going to arrange this system, and then I'm going to act upon it, and then I'm going to assert something about it. That is no different than saying, given this context, when this occurs, then this should be the result. Given when then, arrange, act, assert, who cares? It's just 1, 2, 3. And we do it every time we touch code in a testing way. And so here we have an abstract base class, and real quick, let me turn on a little zoom it tool here so we can do that. So here's our setup, and here's teardown, and note that this is a base class, doesn't actually have anything in it. We're defining some virtual methods, and we're gonna use these in or implement them in our base classes. So what I'm gonna do is I'm gonna take this base class, and I'm gonna create a derived type, and in this case I'll say when, what was our scenario? We were putting something in a shopping cart, right? So we can say when there is one item, and if I could type, that'd be even better, in the cart. Okay, so there we are, we've got a little test going in. Make sure you guys can see that as I do it. What is the problem here? I don't see what's wrong about that. Anybody see it? Human compiler in here. You guys have to see the problem before I do. Oh, it's a class, not a method. There we go. Okay, so this is a derived class from that base, and so I'm going to, wait, I have to check really quick in unit. Sorry, I had to figure out which unit testing framework I was using. So this is a test fixture. And here we've got a test. Actually, before we write that, remember what we have to do. We first have to get our system up and spooled into context, right? In this case, it's a shopping cart. So because we have that base class, we can override our arrange. And we can say in here that we want our we want a shopping cart. We're going to call it cart equals new shopping cart. Now I'm going to take this thing and I'm going to split it like so. I want it to be a field. There we go. Okay. And so the next thing we want to do is what? Somebody talk. This is driving me crazy. Thank you. Yes, sir. Okay, before we go any further, my father-in-law is from Ohio, and I have to hear about it all the time. He lives in Seattle now, but he always has to tell me about the great event of the defining event of his life. Now remember, he's probably a little bit older than some of us in here, but I'll bet you there are some others in here who just might remember this. So I'm trying to figure out which city he's from in Ohio because I don't remember, but now you're going to tell me. Apparently, the river in his town lit on fire. Where was that? Cleveland. He's from Cleveland. Thank you very much. I didn't know if it was Cleveland or Toledo. So yeah, I have to hear about that every Thanksgiving, man, about how the river caught on fire and stayed on fire, right? Anybody see this? Anybody in here? Well, good. We're all younger than my father-in-law. All right. What are we going to do to this cart? Add an item. Let's put something in it. How about a new item? Okay, now we're at the point where we can assert something against this thing, right? Because we've arranged our system, we've acted upon our system, and now we want to assert something. So to do that, I'm actually going to, oh wait, I have to remember which unit testing framework I'm using again. I'm using in-unit. So we're going to say public void, let's see, when one item in cart. Oh, actually, that's the name of the class. When there's one item in the cart, then the item count is 1, something like that. There we go. And so here we can simply assert that the item count is equal to 1. There we go. So once we've done this, we've done some things that are inherently good testing practices almost on accident. What we did was we got our test rig here down to about a line per method. Now I'm not saying that that's an ideal goal or anything, but this works out to make really short little readable methods. And it breaks up the work that we're doing into nice and reasonable components. And so now that we've got this, we can go ahead and run it. I'm using ReSharper. That's the ReSharper unit test runner. And that passes. Okay, great. Well, that's all well and good, but that's really nothing more than a way to write a unit test in sort of this vernacular that we've been talking about. The real goal, if you'll recall, that we're after is to get testers to write these tests. Do you think testers could write what I just wrote? Maybe not filling in the implementation, but could most of our QA specialists come in and maybe develop a set of classes that look like this, right? And then maybe inside here we say something like assert.fail, right? And they say to me, Dave, it's now your turn. Take this code and make the test pass. Is that reasonable? It's a little more reasonable, but still, there are all sorts of design problems and considerations with this. And I can tell you that for the most part, in the teams that I meet out there in the field, the testers are not going to work at this level. It's just not happening. So, what else can we do? Who knows what that is? What is this?
It's the Gherkin language is used to give them like that context, number and spec flow.
Yep, cool. I was actually just kind of hoping for the fact that gherkin turns out to be a vegetable. I didn't know that until I got into this. I actually thought gherkin was a unique word. It's not. It's a type of cucumber. Who knew? You guys know that? You knew that? Really? Well, yeah, but they were pickles, not gherkins. Well, apparently it's a thing. You knew that. Here's another thing. Turns out this laptop that I have here is one of those new Lenovo's where you can touch the screen. I bought it for Windows 8 because everybody knows it's going to be awesome when you touch the screen. Not so much. And the one thing that I've done to get my extra $200 worth of money that I had to pay for the touchscreen was to draw that pickle on it. I drew that pickle on my touchscreen, so there you go. 200 bucks of value right there. Okay. So yeah, there's this thing called gherkin. It's a domain-specific language, the intent of which is to be able to write these little expressions in such a way that testers can write them very easily, that people can write them very easily. Oh, and by the way, machines can read them too. That's the whole idea. Remember that we were looking at this structure earlier, and in fact, it does use exactly this in order to as a I want structure. That's what gherkin asks us to, that's the structure gherkin asks us to use. Now there's a feature here. There's this little line that says feature. And it's actually not insignificant. It kind of matters because we name this thing. Now let's say we name it scenario 1. That'd be a terrible scenario name. How about add a user? This is the add a user scenario. Well, if we put a title on it, like gherkin requires, then when we run across each other in the hallway, you can walk up to me and you can say, hey, Dave, you know that add a user feature? Yeah, that one. Well, here's the problem with it or whatever. We can talk about it. It's a handle. It's nothing more than a handle. Because if we didn't have that, we'd say, that requirement in order to, as I want, what a pain. So we put a title on it. And the next thing we do is we have these scenarios. Gherkin defines structures for these: given, when, then, and then and. These sub-clauses, all these clauses, are referred to as steps in the Gherkin language, and it turns out that each one of these can correspond to a method inside some class structure, right? And there are many different implementations of Gherkin out there, to be real clear. So I know that if you happen to be in Java, JBehave uses something like this, and there are plenty of others, lots and lots. Ruby has Cucumber. I don't know, have they taken Cucumber structures to Java yet? Anybody know that? There's a tool in .NET. There are several. We're going to look at one called SpecFlow, and it has done that. Uses the Gherkin structure. Now it turns out another thing that's cool about this is that at the time that I pulled this, I think it was about a week and a half ago, there were 47 different languages in which you could express Gherkin requirements. Now if I have this, if I'm able to write this in a fairly structured way, do I still need those Word documents? Well, let's see. Because remember, what we're asking people to do is to write these requirements out ahead of time. So I'm going to kill this little AAA project we have here. We'll load up this thing called SpecFlow. So before we go too much further, let me show you very simply my silly little demo app here. Can't see my keyboard. There we go. Okay, so this would be a CodeCamp website. We're going to add some attendees to it. There we go. Add new. How about Leon's gone, but there you go. All right, and then we can go in, we can edit these guys, delete them, save them, whatever. Okay, so it's very simple, forms over data, no big deal type of app, just there to help us illustrate our points. So what we have is the SpecFlow project. It's just a library project. We come in here and add to this thing a feature that we want to implement. I want to implement the feature to edit one of these users. And you saw that I pretty much had that in there, but I'm going to go ahead and add a requirement for it, and then we'll implement it. So we're going to add something called a SpecFlow feature file. Now I went out and downloaded SpecFlow. It is something that I installed on my machine. In addition to that, I included a reference to it using NuGet Package Manager. If you use that in Visual Studio, you can just pull a copy of SpecFlow, put it into your project. That is not enough. You must also go install it on your box. Okay, this puts a constraint on your build machine. Just think through that. Okay, so this feature is going to be edit, actually a 10D. Let's call it a 10D. And what I get here is something called an actual feature file. Now, the reason this is taking a little bit of time to add is because I'm actually talking to a TFS in the cloud, and so it's putting this stuff in version control as we go. Okay, so I'm going to save you all a lot of pain and not make you watch me type this. So there we go. Oh, that was story queue. Here's SpecFlow. This one. Okay, so there's my feature file, and I've just put text in it that reasonably now somebody who works on my team can use to specify the behavior of this form. That's the idea. Now this is in Visual Studio, but I've done nothing more than create this little feature file, and I typed in a requirement. I keep sitting on your mic. I'm going to have to move that thing. Now remember, the other thing we said is that each and every one of these steps, because remember we called these steps right here, corresponds to a method. Now if we look over here, there's that feature file. And you may notice the little triangle there. which indicates that this thing has a code behind file. Every time I save this guy, it's going to run a custom tool. This is nothing more than a T4 translator that spits out a little code file, and here's that code file. Okay? So there's the code file that got spit out. At this moment, we have a test in there. So I'm going to go ahead and build this, and I can right-click this feature file and select Run Spec Flow Scenarios. Now this is the add-in to Visual Studio. So I can run that scenario, and there it goes, it's running. And you see what we have here, we have a change first name scenario and a change last name scenario, both of which are inconclusive. So at this moment, I have a failing test and I haven't written a line of code. Okay? Who thinks this is something you could see QA folks doing now? Hopefully this starts to look a little more attainable. Thanks. So yes, I'm still in Visual Studio. I wish I wasn't, but I am. I'm in Visual Studio. Although all I have to do is make these feature files. I don't actually have to make any code files, just these feature files. And I make them in a dedicated project, close that, check it in. My continuous integration should fire, right? And now all my tests are going to run as inconclusive. This now becomes the work of the sprint, yeah? Is to make these things pass. So let's look at what that looks like. I add something to, so I'm the developer. Let's be real clear. I'm the developer, now it's my turn to make this thing pass. I'm going to come in here, I'm going to add a new class file. Actually, instead, let me do this. I'm going to add new item. SpecFlow gives me an item template for something called a SpecFlow step definition file. And I get to name that whatever I like. I'm going to be original. Name it step definition. There I go. I'll add it. So you'll note that I'm in a folder here. I've got my feature file, and now I've got the step definition file. Well, the step definition file is going to get bound, basically, in memory at runtime to this feature file. They're going to work together. They are not partials of each other, but they are going to work together. And the way they're going to do that is through attribution. So you see this given. Given I have entered some number into the calculator, right? Well, in fact, we want to have this match our scenarios here. Well, how do we do that? Well, it turns out if we come over here and drag this guy open, remember I'm the developer. The failing test, they're good enough to show me in the failing test the code that I actually have to implement in that step definition file, which is a pretty neat deal. So I'm going to grab that method and go over here to my step definitions. And you can see what they're doing. They're matching on strings between the feature file and this code file. So there's the given attribute. That means this method will fire, and then the when, and then the then. So I'm going to take those out and replace them with my own. There's a when. Remember, I'm pulling these right out of the test runner because these guys who wrote this thing were insightful enough to say, you know, all we really need to do is give the devs the code to make the thing pass, and so we'll just put it as the output of an inconclusive test. So now, to make this thing pass, because I'm so such a good programmer and because I'm on stage, all I have to do is comment them out, and now I'm passing the test, right? So we come back over here. Let's run this unit test. Look at that. So obviously you're not actually just going to comment these things out. You're going to, in fact, write some significant code that knows how to talk to your system under test. Let's look at what this is doing. So this is a function of mspec. It's letting me say, before I run this scenario, do this. And so I've created this helper that says, delete all of the attendees in the database. And then here's my after scenario. Go clean them all up. So got that. Given, I'm editing an attendee. Now what I do when I'm in here is I create, there are a lot of ways to do this. And some of this gets into just personal, preference. But what I'm doing here is I am newing up a concrete instantiation of a presenter because I'm using the model view presenter design pattern underneath ASPX web forms. Everybody cool with model view separation? Okay, so I've got this MVP pattern, and the reason I'm doing that is because I want to tease apart the elements of my UI so that I can make them testable. And so I'm going to instantiate a concrete instantiation of my presenter class, and then I'm going to create a fake or mock view. A view is that ASPX page, right? And I'm just going to pass that in. So the easy criticism of this code is you're not really testing the app, and you're right. I'm testing just below the skin of the web application, where 99% of the functionality is going to live. It's going to live underneath that code behind page. It better, right? You don't have to do it this way. There are other ways such that I could, instead of talking to these objects directly, I could instantiate a web client and make calls over HTTP to the skin of that app and do it there. And a lot of people really like doing it that way. Selenium and Watton are two tools that you can use to do your testing exactly that way. Here though, I'm going to new up my presenter, and then when I press delete, that corresponds directly to an action basically, or a method on my presenter. If I were using model view controller, this would be an action that I'm invoking on a controller. Okay, here's another win. These are from two different scenarios, but they're both in the same step definition file. Remember, here are our steps. Let's find these really quick. When I change the first name, when I change the last name, and submit, and submit. So what we're doing here is we're going to get one method that will serve for both of these, right? And then the other two, this one and this one, will have two methods of their own. Make sense? Now, when we get down here in the then, this is where we would actually want to put out an assert, some kind of assertion. Now, this is definitely an integration test. By design, we want this to be an integration test. If you think about how it was written test first, because somebody on my team, probably not the person implementing it, wrote it. What's cool about this is it forces me to use a model view separation pattern of some kind at the highest level, or I can use the Watton approach where I make my calls over HTTP, could do that. But it makes me decouple the components of my app right away. Now, then I get into my TDD loop. So let's say that I've implemented just, this much. Here's my presenter. I'm going to go into the definition of this presenter. Where is that guy? And it forces me to expose, let's see if this works here. Hey, look at that, zoom it. It forces me to expose all of my hot button sort of action methods right off of this guy. This is the testing point for a web forms application. How many people in here have had to work on a web forms app? Few. They suck. They're garbage. They're horrible. They just create spaghetti code all over the place, right? No, they don't. You do. It's a technology. Here's a way that you can build web forms applications that don't suck. I promise. Just saying. Something to consider. Okay. So as I go about building the functionality of this class, I'm going to uncover new little things that I need to create. Like down here, I've got a command. Here's a little delete attendee command object. Well, that delete attendee command is not really something that I'm going to have a spec on, nor should it be, right? That's too low a level. But I, as a developer, definitely want to use TDD to drive this thing out, and I kind of like the given when then thing. So it turns out that there is a little bit lower level testing over here. We've got developer specs, and these are the ones that I write just as part of my TDD process. And so here's my delete attendee spec. And what I'll do is, let's see, when an attendee is not in the repository, let's jump back up one. Here we go. So we're establishing some context. This is a different testing framework than spec flow. We looked at spec flow, you've seen that, and you saw briefly, whether you knew it or not, MS test. We saw that for a second. Now we're looking at something that is a unit testing framework called machine specification. And some people call it MSpec for short. There it is right there. See that library that's been added in, machine specs. Now what this does is it provides a funky little syntax using lambdas on top of that 1, 2, 3 pattern. Remember the given when then? Well, MSpec calls it something else. They don't call it arrange act assert. That's what I called it in mine. And then SpecFlow called it given when then. MSpec calls it something else still. They call it context because should. It's just a different vocabulary. So we're going to establish some context, and here's doing that. I'm going to spool up that new command. This is the command that I'm testing down inside the internals of this system, and I'm going to share this context across a couple of different test classes. So let's go back to this. Now, because of the fact that we executed this command with that particular ID in it, then it should still be a valid command, and it should execute with an exception. So let's run this and see what happens. When we run this, look at the output. And this, by the way, is pretty significant. We haven't focused a terrible amount yet on the structures of the naming, but look at how that reads. When the attendee is not in the repo, it should execute with an exception. It should still be a valid command. So it turns out that Michelle, back there at the veterinary supply place, I was able to write tests even at this level that she could read. Now, she wouldn't specify them to me because this gets into system architecture, but she could consume them and browse them and say, you know, I don't think this should be happening here. And that's what a lot of people would do. Or that's the conversation a lot of people have. How you guys doing?
David,
Yes, sir.
2 things you haven't touched on yet. This is code. This gets checked in with your code management system just like your everything else that you're writing as end code.
Okay.
And this domain-specific language, it's the customer's domain. They understand it because it's their verbs and nouns.
Mm-hmm.
And that's really significant. It's not coming from us.
Jesse.
I'd say in your world, maybe that's true. I don't know that that's true of everyone. Let me repeat what he said. He said that we're getting this mixture, you can keep me honest, make sure I'm saying it right. We're getting this mixture of ownership because this is code, that feature file. That feature file is a DSL, that is actually code. We're checking it into our repository, so that's a developer thing. But wait a minute, the fundamental specification that we're trying to meet, the requirement itself, that's coming from the client. And there's a domain language in there. In fact, you'll notice that in some of my requirements, I capitalize some words, and that's because those words are part of my ubiquitous language for this particular domain. Let's see. Anyway, things like attendee, right? That's an important word. And the reason I know that's an important word maybe is because Michelle told me that. So are you, do you have experience where there becomes a conflict of interest on who owns this?
No, I'm saying this is all good.
Oh, okay.
It means we're incorporating directly into what it is we do, their verbiage.
Right. So what's really cool about it, in my experience, is that I will read over the specifications that Michelle wrote, let's say, and then have questions about those, and I'll go to the tester or the BA or whomever who wrote those before I start working on them and ask them questions about it, and they'll clarify for me, and we'll probably change the requirement a little bit. We'll probably change the sentences just a little bit. One of the big reasons for that is because it's so tempting to write a requirement like this. When I click the file menu, then do this. That's actually not the level at which we want to specify software. We want to go just one layer above that. We want to specify software one layer above the skin. When I edit an attendee, that's the domain, right? And so we'll work together for a while to ensure that she gets really good at expressing that domain. And so now what's interesting, and this is a whole nother thing that I don't know of a tool that's out there that does this, but I can see how what I would really like to do is parse all these feature files and take all of the domain attributes out of it, the domain words, and build a lexicon for my project. In fact, I think it should work the other way around. Here's an attendee, here's a definition for an attendee, that's part of a model. I then extract that into a requirement. You can see that if you consider these feature files to be very small models, which is in fact what DSLs are. So the goodness there comes from the fact that we must agree on what we're looking at before we get going. And when it runs later and it turns green, it is unambiguously green. I have met that requirement. It is no longer an interpretation of something that used to be in an Excel or a Word document, or hanging on the wall as a UML model that no one's ever read, or whatever. Okay. Did you know, this is no joke, did you know that if you stand up, you increase blood flow to your head by 20%? So go ahead and do that. Up. Look at that, you're 20% smarter right now. Now here's a little known secret. You probably knew the whole 20% thing, everybody knew that, right? Did you know that if you put your hands above your head and you wave them like this, that further increases your blood flow to your head by 5%. And if you do this, you will be 1/4 smarter than you were before you stood up. Come on. Perfect, thank you. Now are we doing better? God, I'm getting a complex up here. After lunch, gotta love that slot. Okay. Any other thoughts? Anybody using this? Is anybody using this in the wild? Okay, so I would love it if you would explain to us how it's working for you. Would you be willing to share that?
Sure.
In fact, let me give you this. Why? Why oh no? Test, test, there we are.
Okay, so with our process, we're doing it in Ruby with a Cucumber, and we're using it to do some functional regression testing on UI and the web pages. So right now we actually have a product owner. So we have a product owner, he's able to write these gherkin and then hand it off to the developers and QA, and then we start, trying to make them pass, fail, depending on what we do. And right now it's working pretty well for us. It's actually gotten to the point that we can get it out faster than usually what he can produce.
Really?
Yeah, some of the times. And sometimes we have to help him with them, that if he tells us something, we can try to make them for him.
How accurate are those requirements when he first writes them? In other words, how much are you going to change them before you get them to pass?
We try not to change the specific high-level gherkin. And most of the time, those are usually set pretty well when we do our test case creation.
Okay. Cool. Thanks, man. Appreciate that. Give the man a hand. Come on. All right. Can you tell us about what you're doing with it?
Okay. I've been doing this primarily freelance outside of work. Because unfortunately I work for the state of Ohio, and the department I work for, it's been real hard to convince them that Agile is actually the way to go. So I've been very much stuck during the daytime, the job that pays my bills, doing a lot of waterfall. And fortunately, I just got assigned a program where they said, go ahead and do it any way you think it should be done. So I'm finally getting to actually pull this in. The first thing I put on there was Spec flow,
nice,
as on the deviation form, because I'm deviating from our normal way of doing it. So I've had great success using this. like I said, in freelance coding, because I'm able to sit down with the person who wants to write this stuff and show them, okay, here's what I think that you want this to do, and here's how I'm going to check to make sure it's doing what you want to do. Is that true? You know, read this over and tell me, is there something I'm missing? Is that true? And they've been able to look at that and start to understand, right, yeah, that is exactly what I was trying to tell you, but you put it in 10 words, what took me 10 sentences to try to describe.
Right.
And so and I've had great success. I love Spec.
Okay, cool, thanks. So for both of these guys, they're using, you said you're using Cucumber, right? So Cucumber and SpecFlow both use Gherkin as a DSL. And one of the attributes of doing that, there's an implication to the architecture of that tool. And one of those implications is that it relies on string matching. You saw that in my generated code file. Let's go back and look at that real quick. So we're back up into SpecFlow. Here's my step definitions. There's string matching between this little line here on that attribute and what's going on back over there in that feature file. I have found this to be fragile. I'm not saying that it's a showstopper, it's not a killer, but it's a thing. And sometimes you get people who go in, reasonably I think, go in and change the feature definition file after the code step definitions have been created. That seems reasonable to me. When you do that, as you might imagine, something weird can happen. And if you just change one character in one of those strings, it's not going to match and hit on this thing anymore. And so, it gets a little out of whack, and you have to go clean it up by hand. And that can stink a little bit. Have you run into that yet, sir?
A little bit, not too much, because I use a lot of wildcards.
Okay.
So I'll actually refactor so that my one task will handle different inputs.
It's a little further than we wanted to go today, but yeah, I mean, your point is made. He tries to make his step definitions very generic so that they'll handle most cases that are fed to them, right? And that makes sense. I don't know how fragile the Cucumber implementation is in Ruby, if at all. Maybe it's not a problem at all. Have you ever run into that?
We have more of a problem keeping track of every single step that we make sure we don't make duplicate step definitions.
Duplicate step definitions. So that's interesting because in SpecFlow, one of the things that happens to be true is that if you do what I did, that is I created a file called step definitions, and you create another file called step definitions, which I've done, so you can actually see it here. So you can see that my delete attendee feature, that has a step definitions file, right? So does my edit attendee feature. Now, if we look at these, given I am editing an attendee, I'm going to open this one. This is the edit one. Given I am editing an attendee. Well, that step is going to be defined in that step definitions file. And so if we come back here and look at this step definitions file, the one for delete, here it is. Given I am editing an attendee. It turns out, if we go over here to the step definitions for the edit feature, it's not in there. Yet we all saw that test pass just a few minutes ago. They're sharing the step definitions. So they're in the same memory space. So if I were to create one here, let's go ahead and just do that. I'll take the one from the delete requirement and put it in there. Take out the implementation, do a build. Build's okay, and let's come up here and run our tests, and it should explode all over the place because there are two step definitions called giving I am editing an attendee. So once you start playing with these frameworks, you find little ways to structure things so that you can take advantage of what we call shared context. This is an example of shared context. It's really not much different than what you saw me doing with the AAA class, where I subclassed it. I was sharing context across multiple test cases in that instance too. But you can screw yourself up with it. and you can get chain to context, and then your tests get really unreadable. It's a fine balancing act between don't repeat yourself and reuse of these shared contexts and the complexity, because you can make them complex really quick. You guys find that? Kinda? Okay, so there's that. Let's pop back over to here. Now, as you probably know, I live a lot in the world of Scrum, and it turns out there's this canonical definition of what Scrum is. It's a document on Scrum.org's website called the Scrum Guide. In the Scrum Guide, there is a definition of something called the Sprint Backlog. The Sprint Backlog is the following. It is the subset of product backlog items selected to be implemented in a sprint, plus a plan for delivering them. That's it. So if you're using Scrum and you guys sit in your sprint planning meetings and you decompose into tasks and you get these very detailed time estimates on those tasks and all that stuff, that's fine. That's a way to build a plan. Here's another one. Build a plan out of failing tests. One of the characteristics of that plan needs to be that we can sum remaining work at any time. So Scrum asks us to do that. Be able to sum the remaining work in a given sprint. What if that simply is the number of tests that have not yet passed? This is a completely valid sprint plan that doesn't require task level work at all. Yes, sir?
But you don't have unless you go through, writing all the test section.
You're saying you don't have them all until you start working in the sprint?
Yeah, unless you basically write the specification in Spec or something, right?
So remember what we said earlier. You're in a sprint planning meeting, maybe you're doing product backlog grooming, whatever. When developers say, yeah, but we record it, right? What if instead of writing in Word docs ever, we always write in those feature files? And it's just a different way of looking at the world. It sort of changes things. It means that when we walk into a sprint planning meeting, we can start it with a pile of failing tests in a DLL that represents the requirements for this sprint. And I've seen some teams be really successful with this. It's crazy. They'll create an assembly that is sprint 1 tests, sprint 2 tests, whatever. And they create all those features in there, and they get that thing to pass, and after the sprint's over, they'll merge it into a higher, collection. But they know this is the work of the sprint, and the way they know that is because the tests are there and they're failing. And those were brought in by, believe it or not, product owners in some cases who got really good at speaking this language. This is pretty cool. So the point I wanted to make there is, if you think about this flow diagram, 10? 15. If you think about this flow diagram, what's going on is we walked into the sprint, we had a few tests defined that were failing, let's say 10, I don't know, whatever it took to get us out of that sprint planning meeting, right? Then, what do the testers start doing? Immediately they start writing more and more and more of these things. And remember that our sum is going up, but by the way, the developers are working just a little bit behind the testers. They're implementing these things. And so since they're working just a little bit behind, we start getting some of these things implemented. Now, somewhere along the way, we can quit as testers focusing on creating more and more and new ones of these, because it's going to take the development team a while to get through all this stuff. So we can move our attention over to that ILT type testing that we were talking about. That, I'm not saying is exactly how it's going to work for you. It is the pattern that I see most often in teams that work this way. And in teams that work this way, I have some really great stories of success. This is really working for people. And it has gotten rid of the ambiguity between people telling us what they want and what we hear and what the software actually does later. I mean, that's the cool part. Okay, so now I'll make some incredibly, ridiculously gross generalizations. But I'm in the Midwest, so it's okay. See, like that. Wow, tough crowd. Okay. There, we can write tests against the views in our systems like this. When we do, they tend to be more brittle than at the next layer down, typically because they are not strongly linked through a compiler or something like that. There's no linking dependency usually. You're doing some sort of HTTP thing. And so just in general, that tends to be somewhat brittle because we'll move our UI elements around, et cetera, and we won't know it until our tests fail. So you can still do it. Watan is a really good tool to look into for that. Models, if you're doing a model view separation pattern of some kind, which I hope you are, regardless of what stack you're on, maybe it's even MVVM, you probably don't need to test your models. I say probably because some people build them wrongly and put logic in them. They should be value objects for the most part, so very little work required there. This is where we tend to tap in. This is where some of us tend to tap in doing this executable spec thing. We're just under the skin here. Now what's cool though is that that next level down is very much open for testing with this structure too. This is where I like to use mspec personally. Now I could just as easily use any other tool, InUnit, MSTest, whatever. I happen to like mspec for testing at this level because it lets me think about the domain objects like entities and services and commands and those sorts of things, queries, in terms of that 1, 2, 3 punch, in terms of context because of it should. I like that. But that's just developer stuff, right? Because when you see it come out in the test runner, you may have noticed it didn't matter which vernacular we were using. All 3 vernaculars printed the same thing in the test runner, and Michelle can read all 3 of those. Mostly what I'm going to have here is unit tests. You may have some reason to have integration tests, but I'm probably going to have more unit tests at that layer. And I'm going to back up just a minute and say that in the model we're using, I mocked the view. So this is not real in the spec flow tests that we're looking at. That's a mock, which is the downside to me injecting my tests right in here, right? That's the downside, is that, yes, sir?
I mean, nowadays, a lot of things are written in JavaScript. That's kind of part of the view.
Yep.
So, how do you think, this thing is going to?
There are some tools out there that are sort of emerging. One of them is Jasmine. Jasmine is a unit test framework and runner for JavaScript, and more are on the way. If you're in this talk, I assume that maybe you use Visual Studio from time to time. The unit test runner in Visual Studio 11, which will release in the next version, is amazing. It runs any unit testing framework out there, including Jasmine, including unit tests against JavaScript, against any language that you can imagine. It's fundamentally different and rewritten so that it is extensible like that. So I can run mspec right inside Visual Studio's unit test runner natively. I can do the same thing with InUnit, XUnit, Jasmine, whatever. So these tools are getting more open, believe it or not, even though we're talking about the Borg here. They're getting more open. And when something new comes along, some new technology piece, whatever it is, JavaScript in this case, of course it's not new, it's going to have a unit testing runner and framework for it. I mean, we can go back to Smalltalk on that. You can even find these for Fortran now. It's pretty funny. So it's ubiquitous, quite frankly. This isn't new anymore. Okay, hopefully you don't have to test much here. If you're having to test much here, you're probably wasting your money, unless you work for a company that builds data access layers, and God knows we don't need any more of those, so quit it. Gen that thing and get on with it. Now, there is some unit testing that goes on here, believe it or not. Is anybody doing this? Does anybody here use database level unit tests? There are tools for this that exist today. It's really interesting to look at. There is a whole body of of conversation around unit testing at the database level, and you can do this stuff, including the vernacular that we've been looking at, the taxonomy of the language. You can do it at the database level when you do things like alter table. It's the weirdest thing. So believe it or not, the tools exist for this, and as you've just proven, the actual use of those tools is like a unicorn, not real at all. All right, so you know how we all have those pyramids, right? Every time you go to a talk, you see one of those pyramids. Well, here's one. And all it's saying is that we want as few tests as possible up there at that GUI level. This is not something that's news, right? As a general rule of thumb, a general practice, you could say I would like to have at least one-ish behavioral type functional regression test, those feature files maybe, per feature that we're working on. Yes, sir? And then finally, the primary body of developer-created tests that we're going to have will still be unit tests, because the primary complexity of our application still lives inside the domain, or at least it should in most cases. So we're probably going to see at least one per class or module or something like that. So that pyramid's still in place. All right. I forecasted I was done there. Sorry about that. We've got one more thing to show you. And that is this. There's another tool that I just wanted to mention. It's not groundbreakingly or fundamentally groundbreakingly different, anything like that, but it's a different take on this problem. It doesn't use the string matching stuff, and it's a tool called StoryQ. StoryQ is an open source project. You can go pull, let's see, let me get this thing real quick. Oh, actually, I forgot. I put them up here. So here, I'm going to grab some text. There's my story. Now, if you guys use NuGet, you know what this packages folder is. This is where all my dependencies live. So I went and I pulled StoryQ off of NuGet. So it installed it here. Now I can go inside my StoryQ folder, and this tools directory got laid down. All of this from NuGet. And I can just run this client. This makes a lot more sense to me than opening Visual Studio at all. So I'm going to paste in a requirement. Now this looks kind of gherkin-ish, and it's close, but there are some minor differences. I talked with these guys, and they're going to actually support the full gherkin syntax at some point soon. And they have a couple different languages here already. They've got Portuguese in Brazil, and what is that? Something in Spanish, isn't it? Gosh, I can't believe I don't know that. Anyway, so something interesting happens, right? Watch, I'll do that again. I'm going to paste content into the left side. This is a little app that comes with StoryQ. You can give this to Michelle, right? Or my mom or whomever. And this is the funniest thing. Watch how when I slide this little, the bar to the right, what happens. My implementation gets a little more detailed. It's like the funniest UI trick in the world. But what it's doing here is it's stubbing out that class file for you. This is the test. Now, the other thing that it's doing is it's taking advantage of the Fluent DSL that is the testing framework. See this thing up here starts with, doesn't even assign to a variable, new story, and then you've just got this Fluent add-on syntax, and it's actually quite beautiful. And it reads nicely, and it's strongly typed. I like that about it. And the thing that I love about it is that my testers don't need to work inside Visual Studio. Nobody who's writing this now has to be in Visual Studio, although the SpecFlow guys are also working on a tool that lets you work outside of SpecFlow, or outside of your programming tool. I don't know that much about it, but I wanted to make sure not like diss them or anything. So I can take this thing and I can come over here and just create a class, and I'll just put it here. I'll create a class here called edit attendee. Come on. It's no hurry, really. There we go. And there you go. And so, oh, this is funny. So it says test fixture. This particular test class was written for the in-unit framework. Well, guess what? In this Visual Studio project, I'm using MS Test. So I'll come up here, flip to MS Test, re-grab it, repaste it, and we should be good this time. There we go. Okay, and so this is going to be edit attendee story. Now let's run this guy. There we go. And so I need to go in there and I need to start implementing those individual steps. Make sense? All right. I didn't get an answer, so I'm hoping that your silence means yes. So what's cool about this too is that not only can I execute it, but I can execute it with a report. When I execute it with a report, let's go and do that. Let's run all the story queue tests. Actually, I'll just run everything. There, all the tests are running. Now while they're running, let's go down into my project here, and I'm going to go into my specs folder, story queue, bin, debug. This is where we're writing out, and I get this little folder created for me. It looks like we're done running. And I go into story queue report. Now if I open this XML file, I really hope this opens in IE. There we go. It applies this XSLT transform to it, and I can read these stories and their associated steps on this HTML page. I dropped this in my continuous integration build out on my little drop folder, you know, the place where Michelle can go look at this file anytime she wants, all through the development process. And you can absolutely see our progress to date just by browsing through these test reports. And I straight up don't need to go to the task level in planning anymore. The plan is implement these features. It's pretty cool. All right, so I think we're about it on time. Anybody have any last questions? Yes, sir.
All right, so it looks like cucumbers are, based on my research, cucumbers being used primarily on the Android platform. Do you know of any other good options for a BDD framework?
On Android? I have to confess some ignorance about the Android runtime. I don't know if that's a full Java implementation or what, but I know that JBehave is probably as popular or more.
It uses a different virtual machine.
Is it a different VM? I'm sorry, sir. I don't know that much about Android stuff. I do know that there is a BDD framework that runs SpecFlow on Windows phones. I also know that I just bought a Windows phone and I still have 20 days to return it.
So I'm sorry, you said JBehave in the Java?
Yes, sir.
Okay,
Anybody have a different answer for this gentleman? No? Anything else? Yes, sir.
Are you aware that you can do reporting like this with SpecFlow?
Yes. SpecFlow also generates HTML reports for us. Or they're HTML, right? Straight HTML. You don't have to go through a transformation there. The point is just about every single one of these tools is going to give you a report of some kind. That report is gold because that is the documentation of your software. Think about that. The tests are the specs, are the documentation. It all rolls into one now. Thank goodness we finally are getting there. And sir, you had one. Yes, sir.
Any books or other publications to kind of dive into?
My favorite book, and I'm sorry that I'm not going to remember the gentleman's name, but it's Specification by Example, is a good book on this subject. And I would start there. It's going to lead you in good places. Gojo? I'm sorry. Say his name because I don't want to slaughter it.
Gojo Adzik is the author of that
Gojo Adzik. Thank you all very much for coming. Have a great conference.